Okay, today we will learn how to estimate the cost of a software. The cost estimation actually involves some like that how much the effort is required to complete each activity and how much calendar time is needed to complete the activity. So these are and what is the total cost of each activity. So these are the actual cumulatively the total cost of the software of a software. The project cost estimation and the project scheduling are normally carried out together, and the cost of the development are primarily the cost of the effort involved into that project, into that not only the cost of the employee, including the hardware cost, effort cost, travel cost, others costs like rent of a house, like electricity cost, etc., etc. So these also hardware, software cost and their maintenance, the travel and training cost, effort cost. So these are the cumulatively the whole cost of the software. The software cost means not the what is the cost of the employee only. The cost actually uh, heating and lighting the office space or cooling the office space, the cost of supporting staff such as accountant, administrator, system manager, cleaners, technicians. So as the whole are including in this cost estimation to be considered. The cost of networking, communications, the cost of internet facility, the cost of central facilities such as library, recreation facility. So these are also included into the cost estimation. The cost of social and security, the employees benefits, if there are some employee benefits. So all these are included into this software cost estimation. So first, what is the matrix for project size estimation? The size of a project is obviously not the number of bytes and the source code occupies, neither it is the size of the executable code. We cannot accumulately say that this is the size, it is 1 megabyte or 1 kilobyte, etc. And on basis of that size, we cannot estimate the cost. So the size of a project is obviously not the number of bytes actually, the source code for the of the source code, but it is the not the also not the executable code also. The project size actually measured into two ways, and the first one is line of the code and the second point is the function point of the code. So line of the code is the called LOC and function point is the FP. We know that line of the code means that it measures the coding activity alone. The various life cycle activities should not be directly considered into this line of measure code. ঠিক আছে? Should line of code count that depends on the choice of the specific instruction. Different programmers may lay out their code in very different ways. So line of code metrics penalize user of a higher level programming language code review. Suppose if your software if you measure your software on basis of line of the code, and on basis of that if you count if you make a charge of the software, if you select the price, then the code reuse you should not use, because in that case if you reuse a code, and then the line of the actual software program will reduce and your software price will less. So this is a problem of line of code metrics. And sometimes suppose you are writing an equation, suppose a is equal to 1 plus 2 plus 3 plus 4 plus 5. You may write this in a single way, or you may write this in another way. A is equal to 1 plus b, b is equal to 2 plus c, c is equal to 3 plus d, d is equal to 4, such a way. So it is taken 4 or 5 lines, and in the previous one it is taken one single line. So your intention would be to write to add more lines, but which is not effective for your software project, which is make the complexity more. Okay. So this is not the actual way, but we can use this line of the code, and we will show how this line of the code helps our software project cost estimation technique. Another metric is function point metric. The It proposed Albrecht in 1983, and it overcomes many of the shortcomings of the line of the code metrics. Okay, so easily it can be computed from the problem specification itself. Now we will find the steps of function point matrix. These are the steps of a function point matrix. The first step one, compute the unadjusted function point UFP using the heuristic expression. We will show the later what is the expression. The next step is to compute the value adjustment factors. And then third step is compute the function point by further refining UFP, that is unadjusted function point, to account for the specific characteristics of the project that can influence the entire development effort. So finally, you have to calculate the adjustment function point on basis of the unadjusted function point and value adjusted function point. And this is the uh, equation of unadjusted function point. It is computed as the weighted sum of the five characteristics of a product as shown in the following expression. UFP is equal to summation of whatever the number of elements of a given type into his weights. So its weight and the number are to be multiplied, and then the next items weights and number are to be multiplied, and the whole summation is calculated into the unadjusted function point. Albert proposed the weight value that varies between 3 to 5. This is the weight value which we have calculated multiplied here with the number of the elements. So this weight value, there are five types of weight value: external input, external output, external inquiries, external logical files, external interface files. So there are three types of weighted value: simple, average, complex, or high, medium, low. And the values are given by proposed by Alberts, and this value between lies between 3 to 15. So you have to keep in mind this table, because in the exam you will found the problems, and this table will not be given to you in time of exam. Next, we have to calculate the VAF, value adjustment function point. VAF is equal to TDI into 0.0, সরি 0.0 নয়, এখানে একটা প্রবলেম হয়েছে, it is a typo error, 0.01. This is actually VAF is equal to TDI into 0.01 plus 0.65. Total degree of influence, or the technical complexity factor, TCF, sometimes we called TDI or TCF, there are 14 parameters identified by the Alberts that can influence this development effort. Okay, so these 14 parameters influence this development effort, and the total degree of influence, also it is called total degree of influence or technical complexity factor. Each parameter is assigned some value from 0 to 6, or sometimes it is used 0 to 5. 0 means it is not present or not influenced, and 6 means the strong influence. 0 to 6 or 0 to 5. So here are 14 basic influence characteristics, TDI or TCF. Okay, so first one is data communication, then performance, transaction rate, processing, reusability, end user efficiency, online update, configuration, multiple sites, operations, change requirements, distributed processing, online data entry, installation. So these 14 characteristics are considered to calculate the total degree of influence or technical complexity factor. So these influences have been proposed by Alberts and have been approved by IFPUG, International Function Point Users Group. Actually, there are some international groups who actually said that this type of characteristics are good for the software engineering, like ASCII. We have learned ASCII. ASCII is one organization who have defined that what are the code values of each and every character. Like that way, like that, IFP is another international organization who said these are the weighted value and these are the characteristic which influence into the software engineering with respect to. And here the adjusted function point, it is equal to VAF into UFP. Finally, we will got. So first we have to calculate UFP. UFP is equal to summation of number of items into their weight. VAF is equal to TDI plus 0.01 into TDI into 0.01 plus 0.65, and TDI is equal to summation of all influences, and influences value lies between 0 to 5 or 0 to 6, and the adjusted function point is equal to value adjusted function point into UFP. Okay. Now, here we will show a problem. This is a problem. Consider a project with following data. Number of EI means here, this is the EI, external input, then external output, external inquiries, internal logical files, internal interface files. Okay. So external inputs with low complexity is equal to 10, number of external inputs with high complexity equal to 10, number of external outputs with average complexity is 15, number of external inquiries with average complexity is equal to 13, number of internal files, logical files with high complexity is equal to 2, number of internal logical files with low complexity is equal to 2, number of external interface files with average complexity is equal to 7. So here we have given the items and then the number of that items and their respective characteristic of it is low, high or average or complex, etc. The system has a very high transaction rate and supports several communication protocols. Calculate the adjusted function point. So to calculate the adjusted function point, we have to first calculate the UFP. UFP means unadjusted function point is equal to summation of the number of files into their weight. So the first is number of external interface, external input with low complexity is equal to 10. So for the low complexity, the weight is for external input, it is 3. The weight of low complexity is 3 of external input. This is external input, then low complexity, that is simple complexity. The weight is 3. So 3 cross 10 for the first one, 3 cross 10. For the next one, number of external interface, external input with high complexity. So external input with high complexity, it is 6. Okay, external input with high complexity, the weight is 6. So 6 into the number of items is 10. Okay, and such a way we are adding and we are multiplying the weights with the number of inputs and adding the summation makes the summation, and finally we get 310. So we have got the UFP, unadjusted function point. After calculating the UFP, we will calculate the VAF. To calculate the VAF, we have to calculate the TDI first. So the problem was defined as the system has a very high transaction rate and supports several communication protocols. So look, the transaction rate, it is the third influence is described here, transaction rate. Very high transaction rate means the complexity is very high. So we have taken the first 6 as it is a high transaction rate. So TDI is equal to first 6 is for high transaction rate. This is one influence, and supports several communication protocols. So several communication protocols are actually makes your system complex. These communication protocols makes your system complex. It is another type of influence. okay, in the data communication. So it is another type of influence. That's why we have taken another 6. So first 6 is for transaction rate, and why it is 6? As it is the high, that is highest preference is given. That's why it is the maximum number. It is 6. We have told that influences lies between 0 to 6. 0 means none, nothing. 6 means high. And the communication protocol is here. The another influence which has several communication protocol. That means it is so complex, and that's why we have taken another 6 value. Now we have calculated the TDI. It is 12. Then we put this TDI into the value adjusted function point. You put the value and calculate it, and then unadjusted function point, adjusted function point, and calculate UFP into VAF is equal to what? Then we will get the FP metric of the given software project, where the number of low complexity is this on basis of this. Okay, so this was the function point problem. And the next type of metric is COCOMO. It is actually heuristic estimation technique and constructive cost estimation model. In this COCOMO model, we use actually uh, line of code. It was proposed by Barry Boehm in 1981. Constructive cost estimation model, COCOMO. COCOMO prescribes a three-stage process for project estimation. COCOMO prescribes a three-stage process for project estimation. In the first stage, as initial estimate is arrived at. First stage হলো initial estimate আসবে. Over the next two stages, the initial estimate is refined to arrive at a more accurate estimation. So there are three types of three stage: basic COCOMO, intermediate COCOMO, and complete COCOMO. In the basic COCOMO, it is the first stage and initial estimation is arrived here, and in the next row it is fine and more fine, fining and fining. So the COCOMO is changed into intermediate COCOMO and complete COCOMO. COCOMO uses both single and multi-variable estimation models at different stages of estimation. Okay. The basic COCOMO. Boehm postulated that any software development project can be classified into one of the following three categories based on the development complexity. Based on the development complexity, what are the complexity, what is the problem arise in case of development. Based on that, Boehm proposed that all software development projects were classified in three classes. One is organic, then semi-detached, and embedded. So in COCOMO model, the important model of software engineering to calculate the software cost, the first the software projects are to be classified in three classes: organic, semi-detached, and embedded. What is organic? If the project deals with developing a well understood application program. So the project is a in case of project deals with a well understood application program. The size of the development team is reasonably small. So the development team, that means the employee who is working on that project, are reasonably little. And the team members are experienced in developing similar types of projects. For example, a calculator project. And team member obviously are experienced similar type of projects, or a little bit of not experienced. In that case, the organic type project we can use. For example, a calculator project. The calculator project is a well understood application. So the requirement is very much clear at the first stage. The size of the development team is reasonably planned to calculate to prepare a calculator. A huge number of employees is not necessary, and the team members are experienced in developing a similar type of projects. Obviously, in case of organic. But in semi-detached, if the development team consists of a mixture of experienced and inexperienced staff. So in organic, there are experienced staff, but in semi-detached, it is a combination of development team is a combination of experienced and inexperienced staff. The team members may have limited experience on related system, but may be unfamiliar with some aspects of system being developed. Unfamiliar with some aspects, that means some functionalities of the system are not clear by the team members, by the developers, and that developers may have limited experience on related system, so the experience is low. In that case, the semi-detached, that type of problem like a payroll system projects are example of semi-detached project. And the last one is embedded. If the software being developed is strongly coupled to hardware, that means the development software is developed software is uh, with hardware and software combination, or it strengthen the regulations of the operational procedures exist. And it that means what is the operational procedure of the hardware system depends on the software. The team members may be limited experience on related systems but may be unfamiliar with some aspect of the system being developed. So the team member will be the limited experience, not heavily experienced, but they are unfamiliar with some aspect of the software. They can understand how the software will be prepared, but they cannot understand how the software and hardware will be linked. Suppose this type of in this type of case, this type of project is called embedded. Like an operating system project is an embedded project, and nowadays the Android projects also are one type of embedded project. Basic COCOMO model. So this is the actual formula of the basic COCOMO model. The effort. The first you have to calculate the effort. Effort is equal to A1 into KLOC of A2. So এটা KLOC to the power A2 হবে. KLOC to the power A2 PM person month. Such a way T dev means time division is equal to B1 into effort to the power B2 months. So here A1, A2, B1, B2 are some constants, and for each category of organic, semi-detached and embedded, their value are different. Okay, the KLOC here used basic COCOMO model, and all the COCOMO model use the KLOC. It is the estimated size of the software product, like kilo lines of code. KLOC means kilo lines of code. We have learned previously LOC, it is line of code, and kilo line of code. That means 1000 line of code is equal to 1 KLOC. T dev is the estimated time to develop the software and expressed in month. The value of the time division is expressed in month. And the effort in the total effort required to develop the software product expressed in person month. The value, the metric of the effort is person month. Per PM is the person month is considered to be an appropriate unit for measuring effort because developers are typically assigned to a project for a certain number of months. Normally, the developer calculates the projects in month. So person month actually one person month means one person in 1 month can do this task. 2 person month means 2 person in 1 month can do this task. If we say 20 person month, that means 20 person in a month can do this task, or 1 person in 20 month can do this task. 20 person month means 1 person in 20 month, or 20 person in a 1 month can do this work. Okay, this is called person month. This is the idea of person month, but actually the person month is not working. The main theme of the person month does not that you if you have 1000 person month, you employed all the 1000 person month in a single month and complete the project. It is not actually done. How the scheduling will be done, that is another way. But this person month is calculated only to calculate the effort, how much effort is required to develop your software. So here is the effort values, that is A1, A2, B1, B2 values of different type of projects. In case of organic, the effort is equal to 0.4 into KLOC to the power 1.05 person month. In semi-detached, effort is equal to 3.0 into KLOC of 1.12 person month. Embedded, effort is equal to 3.6 KLOC 1.20 person month. In case of organic, there are three different values for three different organic, semi-detached and detached. Okay. The basic COCOMO model, in the basic COCOMO model, if we find out the effort and product size, we can find that effort required to develop product increase rapidly with the project size. When the project size is increasing, the effort also increasing. But in the first case, the effort is easily very much increasing than the day by day when the new requirement comes again and the project size again increases, so that the effort also increases. And the effort is very much found here that embedded effort is very much bigger than larger than semi-detached, and semi-detached is larger than organic. So these are the idea of effort and product size. So in case of development time versus product size, when the size of product increases by 2 times, the time to develop the product does not double but rises moderately. When in the first time the development time is so much increases with the size of the project, but when the size is very much nearly the finish of the project, in that time the development time is not increasing in that way of the first stage of the software. Okay, here is a problem. Assume that the size of an organic type software product has estimated to be 32,000 lines of source code. So 32,000 lines of source code means 32k kilo line of code. Assume that the average salary of the software developer is 15,000 per month, and determine the effort required to develop the software product, the nominal development time, and the cost of the develop the product. So the cost means here the cost of the employee only, not the whole cost of the software project. So we have got that this is an organic type project. The effort of the organic type project is 2.4 into KLOC to the power 1.05. So here KLOC equal to 32. The value becomes 91. The unit is metric is for PM person month. The nominal development time, that is TDF, is equal to 2.5 into this effort e to the power 0.38 is equal to the 14 month. The staff cost required to develop the product is equal to 91% month into 15. That means 91% we required to develop the project, and 15,000 it is given the software developer price, that is salary is 15,000. So here is the whole result. We can also calculate the average staff size. Average staff size is equal to capital E, that is effort divided by time division. If we divide the effort divided by time division, then it gives us the average staff size. The productivity P is equal to size by E. Size by E. Size means in KLOC and E means the effort. Staff month, sometimes it is called person month or staff month. This does not mean that that is staff minus months, not it is. Actually it is staff month or person month by PM. So KLOC divided by PM, person month. Okay, so that is called the productivity of the software. Here is another problem. Suppose an embedded project has 50 KLOC. So the effort is equal to 3.6 into 50 to the power 1.20 is equal to whatever the person month. And the development time is equal to 2.5 into 394, that is the effort, into the power 0.32 is equal to 17 months. Average staff is equal to 394 divided by 7. Okay, this is the 23 staffs is average required for the project, and the productivity is equal to 50,000 LOC line of code divided by 394 staff months or person month is equal to 127 line of code divided by staff months. Okay, line of code per staff months. So this was the actually productivity. Hello, 127 line of code per person month or per staff month. Basic COCOMO model actually is a heuristic COCOMO model, heuristic technique. It assumes that the relationship that exists among the different project parameters can satisfactory modeling using suitable mathematical operations. The values of A1, A2, B1, B2 for different categories of product as given by the poem are summarized. So The Boehm derives these values by examining some historical data collected from a large number of actual projects. Boehm actually collected a large number of actual projects, divided these projects, find out the characteristics, and he find out that if we use that A1, A2, B1, and B2 values in this way, then we can get a optimized result of the software value of our software project. Okay. Once the basic parameters are known, then other parameters can easily determined by the substituting the value of the independent parameters in the corresponding mathematical expression. Okay. So that's why it is called heuristic. This question প্রায়ই আসে that why the basic COCOMO model is called heuristic. The answer is all the values of A1, A2, B1, B2 are different categories of the project, and actually they are been calculated some historical data of some large number of actual projects, and that's why it is called heuristic. Intermediate COCOMO. After calculating the basic COCOMO, it has been found that basic COCOMO model assumes the effort and development type and functions of the product size alone. However, a host of other project parameters beside the product size affect the effort as well as the time required to develop the product. We calculate, we count only the kilo line of code, but we cannot understand what is the complexity of that code. That if you write a is equal to a plus b, this is one type of complexity, and if you write a is equal to whole to the power 2 into 3 into e divided by cos theta tan theta, so that is the another type of complexity. So these type of complex programs are not calculated into the basic COCOMO model. So the effort to develop a product would vary depending upon the sophistication of the development environment. The intermediate COCOMO model recognizes all these relevant parameters and refines the initial estimates also. The intermediate COCOMO model actually uses a set of 15 cost drivers. 15 cost drivers are considered into the intermediate COCOMO model. These cost drivers determined based on the various attributes of software development. Okay, these cost drivers are multiplied with the initial cost and the effort estimation to be done, approximately scale up. So we will show that these are the 15 parameters. In general, these cost drivers identified by Boehm can be classified into these four classes: product attribute, hardware attribute, personal attribute, and project attribute. Each of these 15 attributes, and these are the attributes under the product attributes: required software reliability, size of the application development, complexity of the product. So these are the attributes under this product attributes. These are the attributes on the hardware attribute. These are the attributes on personal attributes. So each these 15 attributes, each these 15 attributes receives a rating on a 6-point scale. On a 6-point scale: very low, low, nominal, high, very high, extra high, etc. The product of all effort multipliers results in an effort adjustment factor. So whatever these cost drivers affect to your system, you multiply all these cost drivers and you calculate the effort adjustment factor, EAF, and then you multiply this EAF with the basic COCOMO model, that is A1 into KLOC of B1. Okay, and you will get the intermediate COCOMO one. And the next type of COCOMO is called complete COCOMO. A major shortcoming of both the basic and intermediate COCOMO model is that they consider a software product as a single homogeneous entity. They think the whole software product is a single homogeneous. But however, in real life, the most large system made up of several smaller subsystems with widely different characteristics. Okay, a big system, for example, some subsystem may be considered as organic type, some may be semi-detached type, some may be embedded type. So the whole project is not embedded type in a single, or whole project is not single as a organic type. It is a combination of different types of modules. Okay, so these are considered into this complete COCOMO. So complete COCOMO, it has been done, not only the inherent development complexity of the subsystem be different, but the some subsystems are reliability requirements may be high. For some, development team might have a previous experience of similar development. So what they have done in the complete COCOMO model, the cost to develop each subsystem is estimated separately, and the complete system cost is determined as the subsystem cost. This approach reduces the margin of error in the final system. Okay, so individually you apply the COCOMO model of different modules and then you calculate the whole project COCOMO whole project's cost. The estimation models such as COCOMO are not totally accurate and lack a full scientific justification. Still, software cost estimation models such as COCOMO are required for an engineering approach to software project management. The companies considered computed cost estimates to be satisfactory if these are within about 80% of the final cost. So COCOMO still is not the best way to develop adjust to find out what is the actual cost of the software project. But companies considered this COCOMO model, and they considered only if the 80% in 80% case sorry in case they have found the 80% value of the final cost. In that's why the COCOMO complete COCOMO model is the COCOMO model is considered in company. Here is a problem. Just write down, note down this problem, and calculate the. Here it is given the size of the problem project, the cost drivers, software reliability 1.15. That so software tools this. So these are the effort adjustment factor. These are these 15 attributes of your project. The first one is look software reliability. Look here the software reliability. Software engineering capability is one of the attribute. Okay, so this is called software reliability. No, sorry. Required software reliability. This is the product attribute. Required software reliability. So the value is 1.15. Then the software tools, use of software tools. This is in the project attributes. This is use of software tools. So these are the 15 attributes, and we have to calculate the EAF, effort adjustment factor, by multiplying this 1.15, 0.191, 0.85, and 1. And then we have to put this value with the basic COCOMO model, that is A1 into and A1 into KLOC to the power A2. Okay, and the value of the KLOC is different cost drivers of operating system. So this is an operating system project. So the operating system project is an embedded type project. So when we calculate the basic COCOMO, we will think that our project is an embedded type project. After calculating the effort, we will calculate the time duration and the average staff size and the productivity of the software. You do it in yourself into your home. Thank you.